The topic that we're going to discuss is matter, and it's something that every one of you should be a bit familiar with. I know that you covered it in 7th grade and probably a bit in 6th grade. Matter is everything that has mass and volume. So every physical thing in the universe that has mass and volume is matter. And all matter is made up of atoms, which are particles too small that we can see with the human eye. Now, again, all matter has mass and all matter has volume. So let's talk about what mass and what volume is. Mass is the amount of matter in a substance, and it's measured in grams. So if I ask you in a lab to find the mass of an object, what are you going to do? Well, you're going to go and get a scale and put it on the scale and find that mass in grams. Volume is the amount of matter that an object takes up. The amount of space that an object takes up. And it's measured in cubic centimeters, or cm3. In other words, it's how much space it covers. Mass and volume are two physical properties of matter. There are other physical properties of matter, as we're going to discuss. Now, one of the other physical properties of matter is the state that it's in. And when we talk about the state of matter, we're talking about, is it a solid, is it a liquid, or is it a gas? And there's one other state of matter, plasma, which we're really not going to deal with much this year. Plasma is a high energy state of matter, and it's not generally found on Earth. There is one exception to that that we experience quite often here in East Texas, and that's lightning. Lightning is made of plasma. It's a high energy state of matter, and it's something that you really don't want to come in contact with. Now, another physical property of matter is density. Density is the amount of matter in a given amount of space. Now, I like to use the example, if you have a bucket and you fill that bucket with sand to where it's flat on the top, can you get more sand in that bucket? Well, the answer to that is yes. If you pack the sand down and add more sand to it, then you have created a more dense object. It's how closely packed the particles are in a given amount of space. To find density, and I know you've done this before, but density, there's a formula that you will be using this year, and it will be on the STAR test. Density equals mass divided by volume. So if I ask you in a lab to find the density of an object, whether it be a rock or a hunk of metal or whatever, we would find the mass of that object, we would find the volume of that object, and then we simply do a one division problem, mass divided by volume, and that would give us density. And density would be recorded, remember, mass is measured in grams, volume is measured in cubic centimeters, so the density of an object is grams over cubic centimeters. For example, if we were to find the density of pure water, the density of water is 1 gram per cubic centimeter. If an object has a density of less than 1 gram per cubic centimeter and we put it in water, what do you think it's going to do? Well, if it has less density than water, then it's going to float. If it has a density of more than 1 gram per cubic centimeter and we put it in water, it's going to sink. So that's density. There are other properties of matter as well that we'll talk about this year, maybe. Well, not maybe, we will. First is conductivity. Will it conduct electricity or heat? Malleability. Malleability is the ability of an object or matter to be hammered into sheets. And another word that I left off here, ductile. Can it be pulled into wire? Luster is a property of matter, and luster simply is a description of the object, how it reflects light. A diamond has a luster that is called brilliant. It reflects light very nicely and is very pleasant to the eye. Metals have what is known as a metallic luster. If you think about pretty much any metal, gold, silver, they have a metallic luster. Aluminum, iron, all those different things. You know what? When you see them, you know that they're metal, and that's because of their luster. One other is cleavage. Cleavage is how it breaks. Some things, like a rock or a mineral, when you break it, they just kind of shatter. Glass, when you break glass, it shatters into many pieces. But some objects break along atomic planes or lines, and so they'll have flat or very nicely broken pieces. If you take a look at a piece of salt under a microscope, you'll see that it's a cube because it broke into a cube when it was broken up. That's cleavage. So these physical properties that we've talked about today, we can find often the physical properties are how elements or materials are broken down on the periodic table. We have three groups on the periodic table. We have metals. Again, remember metals, they conduct electricity, they conduct heat, they are malleable quite often, and they have a metallic luster. Then there are nonmetals. Nonmetals will have a luster other than a metallic luster. And that can change from earthy to oily and many other types of lusters. Nonmetals are not good conductors of heat or electricity. Nonmetals are not malleable. If you hit a nonmetal with a hammer, it's going to break and shatter. It's not going to flatten out into a sheet, nor can it be pulled into wires. It's not ductile. So metals are ductile, and metals can conduct heat and electricity well. They're good conductors. That's the difference. And then there's a third group. A few elements on the periodic table is when we start talking about the periodic table itself, you'll see their location, but they're between the metals and the nonmetals, and they're called the metalloids. Well, metalloids, they share properties of both metals and nonmetals. So, for example, because we're all using an iPad, and in that iPad there is some circuitry that uses silicon. Silicon is a metalloid. Sometimes it will conduct electricity, and sometimes it doesn't conduct electricity. And that's why it's a really good element to use in an iPad or a computer or a television, because sometimes it needs to conduct electricity and sometimes it needs not to. So it has properties of both metals and nonmetals, and those are again called metalloids. So thanks for watching this video. We'll see you later on.